Hi, this is Benson from AlchemyJ. This is part 2 of building a noughts and crosses game, aka Tic Tac Toe, in Excel without VBA. We built this game board and the first 3 steps of our AI strategy in part 1. If you haven't watched it yet, be sure to watch that first. You can find the link to the video in the description box below. In part 2, we should be able to finish the game. We will probably need the part 3 to explain how I got those game board states generated in Excel. Anyway, let's get started. Okay, I think we are ready to work on step 4, which is we should eliminate moves that make AI loses immediately. Alright, let's set up the game board to have such scenario first. Okay, let's clear this. Okay. Okay, in this scenario, AI can mark anything here and here, but it will lose on the next turn because the human player can play this. Okay, then it has 3 in the same column, so AI will lose. So what we want is to avoid this situation. Okay, let's leave some space here and write our formula here. We'll lose if player plays this move. Again, I'll copy the coordinates from here, paste it here so it's easier to see. For each of the states here, I want to try replacing one of the dots and see if it matches one of the losing states. So putting index here would help us determine the position to the position of the character we should replace. And there are 9 possible positions, so 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, so we want to replace. What do we want to replace? We want to replace this. Okay. What is the starting position? It should be this one. Okay. And number of characters is 1. Now we want to replace it with an O because it will be the human player's turn. Okay. And I want to fix this row. And after that, we want to see if this match anything in the losing state list, on the losing state list. So we use a match, use the match function. Okay. Losing state list. Again, this is I created this name before, so that it's easier to type in this formula. And the match type should be exact match. If it is greater than 0, that means there's a match. Okay, I want to wrap it around with a if error like before. If it matches, this will return true because it will be greater than 0. So if it returns an error, we return false. Okay. We shall add one more condition here, add one more if, because we should only do this if this current position is a dot. So we want to check whether this start num should be this one. Get one character. We check whether this is a dot. If it is, then we do this lookup. Otherwise, return false. Okay, I want to fix this row. And this one should be column. Okay. Let's copy this formula to the whole matrix here. Let's check this formula again. Looks like I missed this one. So this one should not be F40, it should be 840. Okay, so I fix it here. Should be a dollar sign here. Now copy the formula again. Okay, we see some true value here. True for B1, true for B2, C2, C3, B3. Okay, so that means these moves, if the AI play this move, the human player will win on the next turn. So if we see anything, any true value on each column, then that means this move is gonna make the AI lose. So what we can do here, we can write our formula. Let's name this will not lose on next turn. Okay, it's easy. We just see whether there are really any true values here. This is the range. If this is true, that means the AI will lose. So we change it, add a knot around it, and then copy this formula all the way. Okay, so let's check this. B1 is false. That means it will lose if AI plays B1. Okay, whereas A3, where's A3? A3 here is safe. Okay, because true means the AI will not lose on the next turn. Okay, moving on to step number 5. Pick the move that leads to the most win terminal states. That means we need to take this state pattern here, each of them, and see how many win state it can match. So we have the winning states list here, and we need to do some matching. But this match is not an exact match. It only needs to match the O and X in the pattern. The dots can be anything because dot represents empty position. To do this, we can use a function in AlchemyJ called AJ regular expression count. It counts how many times a pattern is found in a piece of text based on a regular expression pattern. Okay, so let's do this. I will copy these coordinates to here again, make it easier to read. How about to here? I want to pick one that actually has a pattern, so this one. Okay, let's write the formula here. So we use AJ reg exp count. The first parameter is the input string, so we are matching this state string and I will fix this column. Next parameter is the pattern. So it's this one, B1. And I will fix the row here. I think you now realize why I pick dots to represent empty position. Because in regular expressions, the dot is the wildcard pattern which matches any single characters. That means the state string we have been using are actually regular expressions here. Okay, so it's very convenient. Close the bracket, and we only want to do this if this pattern is not empty. If it is empty, then we return 0, because this regular expression count returns a number. Okay, I'll fix this row. Okay, it returns 0. Let's copy this formula to all the cells here. Okay, we see some 1s here. Okay, that means the pattern for this move actually match some winning states. Okay, that's good. To get the total number of reachable winning state for a move, we just need to sum each of these columns. Okay, and let's put the result here. So winning combinations. Okay, just sum the corresponding column here. Copy this formula all the way. Okay, now we can see that the number of winning combination this move can actually reach. Next, I want to see which move can actually reach some winning states. That's easy. We just check whether these numbers are larger than 0. Okay, so can reach win state if this is greater than 0. Okay, so by looking at this row, we know which move will lead to some winning states. Then we want to find the maximum winning combinations, because we want to pick the one that leads to the largest number of win states. However, we cannot just get the maximum of this range here, because of step 4 of our strategy. Okay, we cannot pick a move that will make the AI loses on the next turn. So we need to use max if here. Okay, so let's name this max winning combination. Okay, let's enter the formula using max if. The maximum range, okay, this is the range we want to find the maximum. The first criteria is we just want to pick those that can reach a win state. So the criteria is true. The second criteria is we will not lose. This one is also true. Okay, let's see. I want to fix this. Then we find out which moves match such the number of combination we just calculated. Okay, this Let's name it possible winning move. Again, we can only use move that does not make AI loses on the next turn, and it is a winning move. So we use N for all these conditions. So the first one, it can reach a winning state, and then will not lose on the next turn. Okay, I want to fix this row. And then we check whether the maximum winning number, the maximum winning combination equals to this, the winning combination of this move. Okay. And copy this formula across the row. Finally, we find the first move that matches all criteria. It is possible that none of the moves can reach a winning state, so try this. Select it. Possible winning move. So we use index match. We wanted to return one of this, and then we use match to find the index. Lookup value is true, and the lookup array is this range here, and we need exact match. Cross. Okay, A3 here, so it picks the largest one. Okay, I want to create a situation that the AI would not pick the largest number here, because one of it is will lead the AI to lose on the next round. Okay, so we set up the game board here. About X here. Okay, maybe this situation. B2 and B3, they both have 2 winning combinations. However, the AI selects A3 because B2 will make the AI lose on the next round. A3 will not. That's why it returns A3, which is correct. Good. Let's see if it works by playing a game with the AI. So I clear the game board. Okay, human goes first, and he takes the center position. So I mark O. Okay, AI finds A1, C1, A3, C3 are all possible moves. They can lead to the same number of winning states, 46. This makes sense. Remember we talked about game board rotation and reflection. Playing any of these corners, here, 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 and here, are actually the same move. Okay, so I follow the decision of the AI. I place a cross on in cell in A1. The human player tries to win by marking A2. AI finds that C1 can reach the most winning states. However, will not lose on next turn is force. That means this move C1 will actually make the AI player lose on the next round. So it picks C2, which actually blocks the opponent. So I put a cross here, C2. Then we try to win by marking B1. This time, our AI cannot find any possible winning moves. This leads us to the last step of our strategy, which is to pick the move that leads to the largest number of draw states. We can use the same method we use in looking for the winning moves here. Before we do that, I should fix this row here so that I can copy this formula for draw. Okay, so we can copy these 5 rows and just paste them here. Let's change the labels first. So this becomes draw combination, draw state, maximum draw combination, possible draw move, selected possible draw move. Okay, we need to change the range here, but before we do that, we should copy the regular expression. This one, we just use this one. Copy it down here. Okay. Okay, there are some ones here. That means it can reach some draw states. Okay, next we go back to fix this formula. The rows, the column the rows we should sum would be this column here. Okay. Okay, then I copy this formula. Alright, so now it says that the selected possible draw move is B3. So we should play, AI would play B3 here. It actually blocks the opponent. Okay, it's a good move. That completes the last step of our strategy. We can fill in the formula G5 here to show which moves the AI chooses. Okay, equal if we check whether AI's turn is true. If it's false, if it is false, that means it's human's turn, so your turn. Okay, let me close this. Okay, so if it is AI's turn, then we check if error. If we first consider the winning move. If it is error, then we consider the possible winning moves. If it is still an error, then the draw move. If we can't reach the draw move, that means we cannot win. Okay, let's clear the board and try to beat our AI. So I will go first. I pick this corner. So AI will mark B2. Okay. Looks like a good move. Then I play A3. So it blocks me. Okay. Now I need to play C2 to block AI. Then whoa, it's getting aggressive, huh? X1. So now I must play B3. Then AI select C3. Okay, so it's a draw. We are done. Of course, you can format this game board and make it look better. Okay, let me make this more looks more like a square. Okay, change the format. Okay. Maybe we select a better font. How about the ink free font? Oh, this looks nice. Bold it. Maybe add some background color. This video is getting quite long, so I will explain how I generate those terminal states in Excel in a separate video. We'll put a link in the description below when it is ready. If any one of you out there try this model, try to build this yourself, and is able to beat the AI, be sure to let me know. Finally, if you enjoyed this video, please like, share, comment, and subscribe. Before you go, let more people know about AlchemyJ. It's a fantastic product, it's free, so please go download it and check it out. I shall see you in the next video. Bye.